Hello everybody. In this video we're going to learn a new exponential functions which has a base e. What we know so far, we know a basic formula for exponential function which is y, y equal to a, which is initial value, multiplied by b to exponent t. We know if b is more than 1, the function is increasing, and if b is between 0 and 1, the function decreasing or decaying. Now we're gonna learn about continuous growth rate. What we do, we're gonna bring e. Instead of this b, I'm going to put e to power of k. Let me change the color, that's wrong. So e to the power of k, it will be our b. So the new formula will be y equal to a e to the power of k, which is b, to the power of t. This will be a e k multiplied by t. So for continuous growth rate, we use this formula. If this k, which is a continuous growth rate, so this is k, if k is more than 0, then y is increasing. If k is less than 0, then y is decreasing. So before we go to the word problem for using this formula, let's have some algebra practice. All right, first example, I give you guys a function like f of x equal to e to power of 7 minus 3t. And my question is, what is a and k, or make this one to continuous growth rate function, like f of x equal to a e k to power of t. So this one, we have to make it to this form. The good news is we see e, and our model has e, so we don't need to worry about that. So what I'm gonna do, we're gonna have e to power 7 minus 3t equal to e to power 7 multiplied by e to power negative 3t. Well, this will be, and that's it. So e to power 7 will be our a, and k will be negative 3. You can calculate e to power 7 through your calculator, or you can keep it as an exact value. E to power 7 is a number, negative 3 is k, and k is less than 0, the function is decaying. Let's have another example. G of z equal to 5 e to power 7z multiplied by e to power 4z multiply 3 to power ez. they're asking us to make this one to g of z equal to a e to power k z. Basically, in some of the word problem, we need to calculate k. We need to be able to tell, is this function increasing or is decreasing? So we have 5. So all of them are multiplication, and 3 here. So 5 times 3, we get 15. Then we have e to power 7z, e to power 4z, and e to power z. One of the properties of exponent was if you have a to power m times a to power n, we will write one of the base and add the exponent. So that's what I'm going to do. We're going to have 15 e 7z plus 4z plus z. This will give us 15 e to power of 12z. So now we can say that a initial value is 15, k, which is continuous growth rate, is 12, and z, which is independent to g of z. Let's have one spicy question here. Same topic, I give you guys a function. This is q of t equal to radical e exponent 3 plus 6t, and they're asking us make this one to a times e to power k t. So we need to find the initial value, and we need to find growth rate, continuous growth rate. So back to this equation, we have radical. I will make the radical to the power of 1/2. So we have e 3 plus 6t to power 1/2. This is same as one of the property of exponent. If you have a to power b to power of m, this is a to power b m. We multiply. So here we have e 1/2 multiplied by 3 plus 6t. This equal to e to power 3/2 plus 1/2 times 3 is 3/2, 1/2 times 6 is 3t, which is great. This equal to, so this is addition, I can break it down. So the same formula, a to power m plus n, this is a to power m multiply a to power n. So what I'm going to do, I'm going to break it down, e to power 3/2 multiply e to power of 3t. E to power 3/2 is a number which will be our initial value, and k, which is a growth, continuous growth rate, will be 3. I think that's enough.